Hello, everyone. There's been some issues about the density experiment that's going to be due this Friday. So what I decided to do was to give a sort of tutorial on how to work this particular experiment. But a few people have actually emailed me and they're not quite understanding it. So I decided to, these are different numbers, of course, than what you have, but this will give you like a general guideline on how to actually work the experiment itself. Um, I thought it was pretty clear, but there may have been some hiccups in here. So let me clarify. So first of all, you've got, of course, your part one. You got the massive empty flask and stopper and massive flask, massive water, flask, stopper. And they say, what's the mass of water? Well, that's going to be straightforward, a subtraction. Okay. And like I said, these are my numbers, not yours. We got 23.54 minus 11.54. Okay, that equals 12. We're starting off with 12 grams of mass of water. Now, to figure out the volume of the flask. Now, the volume of the flask is never going to change as far as volume of the flask. We're going to assume the volume of the flask is equals the volume of the water in this particular case. So basically, the density of water is 0.9970. Okay, so to get the volume of the flask, take the 12 grams and divide it by 0.9970. Okay, and this gives you 12.04. This is gram per milliliter. So like I said, you're going to see this quite often throughout the lab. Gram per milliliter. Oops. Back up a little bit. So it says gram per milliliter. Now, let's go down here. We've got the massive empty flask stopper, number there. Mass of flask, stopper, and metal. Massive flask, stopper, metal, and water. Okay, so mass of metal. They ask for the mass of metal. All right, that's straightforward. You take the 21.50, okay, which is, of course, your mass of flask, stopper, and metal. Subtract that, so minus 11.54, okay, which is mass of empty flask stopper, equal, all right, 9.96. This is grams. All right, mass of water. Mass of water, take the 32.50, okay, minus the 21.50, okay? So think of it like this. This is mass of flask, stopper, metal, and water. This is mass of flask, stopper, metal. So you get the, basically get the water. This has got all of it. That minus that, just give me the water left. There we go. Equals, and that is 11 grams. And this is also technically grams. Oh, all right. Volume of water. Okay. Now, we have the mass of the water, all right? Get the volume. Basically, you're going to take the volume is equal to density. Sorry, mass divided by density gives you volume. So mass, 11 grams, divided by the density. Now, the density, as we said before, up here was 0.9970. Okay? Equals, in this case, actually, move this over a little bit. Probably should move it over some. Okay. That equals 11.03. This is gram per milliliter. Oops. Grams per milliliter. All right. Next, volume of metal. Okay. So volume of metal is equal to the volume of the flask minus the volume of water. Okay. So basically 12.04. Okay. This is back up here, right here. So this is 12.04 milliliters. This is the volume of the flask. Okay, that's in milliliters. Okay. So volume of the flask, 12.04 milliliters minus volume of water, and that's the 11.03. Sorry, this my fault. This a mistake I made. This is not gram per milliliter, it's simply milliliters here. There we go. This is in milliliters. Okay, minus 11.03 milliliters equal, okay, 1.01 milliliters. Right, density of the metal. Density, as we know, is mass divided by volume. Okay, so this is my mass of the metal, 9.96. Volume of the metal, 1.01. So 9.96 grams divided by 1.01 milliliters equals 9.86. This is gram per milliliter. Okay. Move on down here. Part 3. All right. Part 3, we have 3 standard solutions. Solution 1, 2, and 3. Okay. Massive empty flask as stopper. That was copied from above. So go way back up here. Right here. Okay. So this is grams still. All right, massive solution 1. So standard mass solution 1 is all subtraction. 23.54 minus 11.54 will be over. Okay, equals 12 grams. Now density is going to be the mass divided by the volume. Okay, now remember, so mass, and these are all liquids. So the volume is going to be the entire liquid of, or the volume of the entire cylinder. The volume of the entire cylinder, flask, basically, was way back up, was what? 12.04. That was the volume of the flask, okay? So, mass, 12 grams, divided by volume, 12.04 milliliters. This gives you 0.9966. This is gram per milliliter. Pretty much just repeat the same thing for all of these, all right? We have mass of flask filled with solution 2. We're going to take this minus our 11.54 again. So 24.25 minus 11.54 equals, let's see, 12.71. Okay, this is grams. Once again, density, same thing as before, 12.71 grams divided by, and it's going to be 12.04 milliliters. equals 1.12 gram per milliliter. Like I said, these are different numbers than what you have, but you should be able to figure this out with the template, okay? Let's see, here we go. Solution 3. Pretty much what we did before. Take the 25, in this case, minus, or 25.00, okay? Minus 11.54 equals, let's see, what was that? 12.96. Okay, this is grams. Density, mass divided by volume. So 12.96 grams divided by 12.04 milliliters equals 1.0, no, sorry. Oops, I'm sorry. I did make a mistake. Got my number shifted. This is 1.056. 1.056. This one is 1.12. And hold on. Hold on, 12.20. Hold on a second. Yep, okay. That's a good thing I'm recording this. Let me back it up a second. I got some of my numbers shifted off. Okay. See, 12.71, this is fine. These numbers are wrong here. Let me fix this. 25 minus 11.54, this is 13.46. 13.46. I apologize for that. I did this like real quickly. 13.46 grams. So we have 13.46 divided by 12.04. There we go. Okay, 13.46. This is solution number 3. So 13.46 divided by 12.04. This is equal to 1.12. Okay. Milliliters. Or grams per milliliter, actually. Gram per milliliter. All right, last but not least, move a little bit. Last but not least, the unknown. So, got the mass of the unknown. The same thing with it. Take the 24.5, subtract it from basically 11.54, as we've been doing. This equals 12.96. I do apologize for the numbers being shifted here and there. Like I said, I made this up real quick because I had like 5 or 6, maybe more than that, people email me on this particular lab. Now, to get the density, same thing, mass divided by volume, 12.96 grams divided by, volume didn't change, 12.04 milliliters equals, move him over a little bit, 1.076. This is gram per milliliter. All right, now all that's left is to fill out the table. Okay, so got 12 grams here. We have 12.71 here, grams. We have 13.46. Grams here. And we have 12.96 grams here. Volume of solution is 12.04 across the board, milliliters. So you can just go copy and paste. Copy, and we paste it. And paste that, and there we go. Same thing, volume of solution. Density, okay? 0.966, okay? It's gram per milliliter. I'm not gonna put the units in, but on this, 1.056 here. Oops, 56. Then 1.12. Last but not least, 1.076. Okay, these are all gram per milliliter. So estimate. The question was basically you wanted to estimate on this one. Estimate the percentage. This is 10%, 20%, 30%. And these percentages, these are the densities we got. So question is, what is the density of the unknown? Well, this is 1.056 or so was about 20%. 1.12 was about 30%. So my estimation on this would be about maybe 22% or so. So we say estimate concentration. For the unknown is about, in this case, 22%. And that's it. So, and trust me, I'm probably won't be doing this again. This is one of those, but there was the only reason I even decided to on this was a lot of emails given off, and there was no YouTube video on this particular one. Okay, what I will do is, I'm gonna save this, stick it on YouTube, and send a link to you all. And there we go. So of course, save it, name on it, put it in a Dropbox. All right. Enjoy the rest of your evening, and I will get this link to you.